most people solve this problem but don't actually understand why it works. So today we are not just solving it, we are understanding it in the simplest way possible. Hi coders, I am Shraddha and welcome back. And today's problem is container with most water, LeetCode 11 medium. Now when you first read the problem statement and vertical lines, coordinates I, 0, height of I, container water, it sounds complicated, but relax. Let's simplify this completely. Imagine you have a graph paper. There is an x-axis and y-axis. Yes, x-axis means positions like 0, 1, 2, 3, the horizontal one. The y-axis means the height, the vertical one. Now, at every position, you draw a vertical line and height of that line is given in the array. So, if the array is like this, that simply means at position 0, height is 1, at position 1, height is 8, at position 2, height is 6, and so on. So basically there are just vertical lines of different heights. Now here comes the interesting part. You can pick any two lines and imagine filling the space between them with water, or even just color that area like with a pencil. That filled region is your container. Now the question is, how much water can this container hold? And here it's something very important. The problem says container, but this is not a 3D container. There is no depth. We are looking from the side view, so we are not calculating the volume, we are calculating the area. Simply a rectangle, and we are looking for maximum area. So how do we calculate area? Width into height. Width means how far apart the two lines are, right index minus left index, and height means how high the water can go. Now the most important question, which height do we take? The taller line or the shorter line? Think about this. Left line is height 8 and right line is height 3. You pour water, what happens? Water spills from the shorter side at 3. So it can never go above 3. So water always depends on the smaller height. That's why we take the minimum. So our formula becomes area is equals to right minus left, which will be our width, into minimum of height of left comma height of right, means we will take minimum from the both. Now the problem is simple. Find two lines that give the maximum area and return that area. First thought, try every pair. This with this, that with that. Yes, it works, but it's too slow, which is brute force, big of and square complexity. So we need a smarter way, and that is 2 pointers. Now this is the most important part of focus. We place one pointer at the start, one pointer at the end. This gives us the maximum width possible. Now here is the key idea. Width is going to decrease anyway because both pointers are moving towards each other. We cannot control the width. So what can we control? Height. So our goal becomes try to find the better height while width decreases. Now the big question, which pointer do we move? Here is the logic. The water level depends on the shorter height. That is the bottleneck. So if we move the taller height, nothing improves because smaller ones is still limiting us. But if we move the smaller height, we might find a taller one next, and that can increase the area. So we always move the shorter pointer. Now let's see the example quickly. Given is this array. Best answer becomes between height 8 and height 7, index 1, index 8. Width is equals to 8 minus 1 equal to 7. Height is equals to minimum of 8, 7, which is equal to 7. Area is equals to 7 into 7 is equals to 49. Notice something interesting. There are two 8s in the array, but they are not the answer because width between them is smaller. Also remember this, it is not just the height, width also matters because area is product of both, and for the maximum product we want both to be as large as possible. Let's understand this through an example. Given is this array. We start with 2 pointers, left at index 0, height equal to 1, right at index 8, height equal to 7. Now calculate the area, height equals to, which will be the minimum of 1 and 7, which is 1. Width is equals to 8 minus 0 is equals to 8. Area is equals to 1 into 8 equal to 8. So max area till now is 8. Now, which pointer moves? Left is smaller. 1 is smaller than 7, so we move the left forward. Now, left is equal to 1, height equal to 8. Right equal to 8, height equal to 7. Height equals to mean of 8, 7, which is 7. Width is equals to 8 minus 1 equal to 7. Area equal to 7 into 7 is equal to 49. So, this is bigger than what we had earlier. So, max area equals to 49. Now, which pointer moves? Right is smaller. So, 7 is less than 8. Move the right backward. Right equal to 7, height equal to 3, height equals to mean of 8 comma 3 equal to 3. So width is equals to 7 minus 1 equal to 6, so area equal to 18. And we go on like this till left and right are about to meet. Once they meet, we stop. So final answer is 49. Now let's understand the code quickly. We start with left equal to 0, right equal to array length, which is height dot length minus 1, max area equal to 0. Now we run a loop while left is less than right, means still both meet. Inside the loop, first we calculate the height, means minimum of height of left comma height of right, because water depends on the smaller height. Then width equal, how we calculate the width is right minus left. Then area, height into width. Now we update the max area. Maximum of the max area till now we have, and the area, which is the current heights are given. Now comes the most important step, pointer movement. So if left height is less than right height, move the left forward because left is the bottleneck. Else move the right backward. We repeat this until left meets the right and finally return the max area. So time complexity is big of n because we are visiting every element only once, only one pass, and space complexity is big of 1 because no extra space. So quick recap, area not the volume, height equals to smaller line, width is equals to distance, right index minus left index, start with the maximum width, move the shorter pointer, track the maximum area. And just like that, we cracked the today's problem. If this made sense, drop a comment and tell me, did you understand why we moved the smaller pointer? Like, share and subscribe to Let's Crack It. And thank you for watching. Till then, happy coding.